Hello everyone, welcome back to Code Studio. In the last video, we have seen how recursive algorithms are written with a proper procedure, like writing down the base case and the recursive case perfectly and making sure the case holds and not falls in an infinite loop and so on. Videos forthcoming the earlier one would be applications of the theory we have discussed in the first video. We will be discussing some classic problems with their theoretical and mathematical aspects, and then we will jump into coding into C, C++ and Python languages. So make sure you have seen the theory video and recursion series uploaded on the channel before jumping any further. I would also be linking the same in the description below. In this particular video, we will be discussing a classic example of recursion of how to code for the factorial of a number. So what is a factorial of a number? The definition of factorial of a number is n times n-1 times n-2 times so on up to 3 into 2 into 1. So we go on multiplying the value by decreasing it by 1. See, you can see n-1, n-2, and we go on until a 1 is reached at the end. So let me give you an example of how a factorial of a number is calculated. Let's calculate the value of 4 factorial. 4 factorial, according to the definition, can be written as 4 into 4 minus 1 is 3 into 4 minus 2 is 2 times 1, because 2 minus 1 is 1. So we go on multiplying by decreasing 1 until a 1 is reached at the end, and the value of this would be 24. The value of 5 factorial would also be written the same thing, 5 times 4 times 3 times 2 times 1. This is 120. So as you have seen here how a factorial of a number has to be calculated, our major task is to code for a function, basically a recursive function that returns the value of n factorial when the value of n is inputted into the function. So let's find out the general case from these two examples. See here, the 4 into 3 into 2 into 1. This whole sequence can be replaced with a single operation as 4 factorial. So replacing that, we get the value of 5 factorial to be 5 into 4 factorial. In the same way, this thing, the 3 into 2 into 1, can be replaced with a single operation as 3 factorial. And hence, we write the 4 factorial to be 4 into 3 factorial. Generalizing this above fact, we can write down an n factorial can be written as n times n-1 factorial. This is the core operation we require during the course of drafting our recursive function. Basically, this is the thing that drives the recursive function. To draft out our recursive algorithm, we should first define a recursive function and let the recursive function be f of n. Here, f of n is a recursive function. Here, n is the input given by the user into the function. So we need to calculate the value of n factorial. We should set the base case and the recursive case for our function so as to carry out the recursive algorithm. As we have seen on the earlier canvas that n factorial can be written as n times n-1 factorial, let us write this thing in the same way as a functional form. N factorial can be written as f of n and n-1 factorial as f of n-1, and we multiply f of n-1 with n. So this is the recursive case of our algorithm. After setting the recursive case, our major task is to set the base case of our algorithm. The base case is where our recursive function stops calling and returns a particular value. Our function must return a value of 1 when the value of n equal to 0, since we already know that the value of 0 factorial is 1. So the value of f of 0 is 1. Let us take an example and check whether our function is working properly or not. Let us take the example we have already solved, that is f of 4, which is equivalent to 4 factorial, is 4 times f of 3. This can be written as 4 times 3 times f of 2. This can be written as 4 times 3 times 2 times f of 1. And this can be written as 4 times 3 times 2 times 1 times f of 0. And since we have set the base case of f of 0 equal to 1, the answer would be 4 into 3 into 2 into 1 into 1, that is 24. Let us finally write down the recursive function f of n so that it would be easy for us while coding. F of n can be written as n times f of n-1 when n is greater than or equal to 1 and 1 when n equal to 0. The one thing you need to keep in mind while drafting out this is n is always a greater than or equal to 0 quantity, because factorial is only defined for this condition to happen. This is basically the recursive algorithm that we will follow while coding. So let's jump into our text editors and write down in the language of choice. I'll leave the timestamps on the screen here. I'm on my text editor open, and I've saved my file to factorial_recursion.py, and on this particular file I'll be helping you to code for the recursive function we have discussed in the Python language. So basically the first task we need to do is define the recursive function. Let us define the factorial function to be something like factorial_recursion, and let's take an input n into the function. In the mathematical recursive pseudocode, which is visible on the right side corner, we need to write two conditions. If n equal to 0, the function must return a value of 1, and in any other case, the function must return a value of n times factorial_recursion of n minus 1. This is what we have seen in the canvas, that is how to define the recursive function, and I have explained you how to define it on Python. So now let's take an input of number into the code. Let's assume the number to be k, input and let's print the answer in the specified format here in the right hand side corner. I'll be using the format specifiers for this code. So this is how we write the code in Python of factorial_recursion. Let's jump into the terminal and just check whether the code we have written is correct or wrong. So let me run the code here. Let's enter the number 4. So 4 factor is 24, which is right. Let's try for 5, number 5. 5 factor is 120, that is perfect. Let's also try for another test case, that's 0. Yes, 0 factorial is 1. Hence, we can say that the code we have written is perfectly running fine. I'll also be linking the source codes in the description below, and you can have a look on it when you just code on your own and you're stuck upon anything. Let me help you code for the function we have. So let's code for the recursive function in C and C++. You might be thinking why I've opened the two files side by side, because C and C++ are almost alike, and the functions and the process we do is almost similar. So if I can write in C and also in C++ simultaneously, then people who can understand both, and it will also be helpful for those who want to do transition between C to C++. Okay, so let me start with C because C is the basic one. Let me include the preprocessor file. Let me also include the preprocessor files in C++. So let me declare a function here. That's the basic recursive function, and let me name it factorial_recursion. The inputs would be integers, a single integer whose factorial has to be calculated, and this function returns an integer value, hence the return type int here. In this recursive function, we have to include two conditions, that is the if condition and else condition when n equal to 0 and n greater than or equal to 1. So we can write an if condition when n greater than or equal to 1 or n equal to 0. Let me write for n greater than or equal to 1. Okay. So we need to return a value of n times factorial_recursion and into n minus 1. This is what we need to return when the value is n greater than or equal to 1, and in the other case, which is the case when n equal to 0, we need to return a value of 1. Case over here, this is a recursive case, and the case of else is the base case for us. Since the function definition and function working is same in C and C++, I'll copy the same recursive function and place it in the C++ code. Yeah. So let us now write down the main function and continue our main process. So let me declare two variables. Those are n and a value of f, that is factorial. Okay. So let's input the value of n. So let me first print the value and the number. Okay, /n. and then we need to scan the number. And let's also declare the same things in main function of C++. Let's declare two values, those are int and f, and then just print the same message, enter the number, and let's also input the value of n. So let's declare the f variable to be the main result, that is factorial underscore recursion of n. So when the value of n is given into this function, the recursive function runs itself and the final value is returned to a variable named f. Okay, so this f is the main case, and it will be same in both C and C++, right? Now let's print the answer in the specified format as something like the same thing is there with C. Here let's also include the endline character over here. So the final code is completed. So let's run them on the terminals and check whether they're working fine or not. GCC factorial underscore recursion.c. So on running the code, it's asking to enter the number. We'll enter the number to be 4, and 4 factorial is 24. And let's also enter the number 5, and let's check. Oh yeah, 5 factorial is 120. Let's also check for the final test case, that is 0. Yes, 0 factorial is 1. Running perfectly fine. Let's also check whether the C++ code is working fine or not. So it's asking to enter a number. Let me enter 4. It's, oh wait, we have written some mistake, and let me rectify it. So the mistake I've done is using these %d characters. This doesn't exist in C++. Okay, wait. It should be F. That should be N. Yeah, this works perfectly fine now with a little gap now. Yes, this code should work perfectly fine because I've removed the %d characters. I've not given the inputs also to this %d. I've done a simple mistake because I was writing the C and C++ code simultaneously, and I just copied it right here, but we don't use those things in C++. Let me run it again. Let me compile it and run it again. Enter the number. I'll enter 4. 4 factorial is 24. Let me enter 5. 5 factorial is 120. Let me enter the final test case. 0 factorial is 1. Yes, my code is running perfectly well. So a little mistake between transition between C and C++ made this error. Okay, so make sure you don't make such errors when transitioning between C and C++. Alright guys, see you in the next video. Signing off, Saiankit, Code Studio.